So this is a distribution automation system implementation that we're showing here today. And the financial impacts of power outages in the US today is about $79 billion. Utilities need to actively and efficiently distribute power on the grid. They need to detect, diagnose, locate faults, and restore power quickly. By implementing intelligent distribution automation systems, using Maxim's high-speed, high-accuracy, high-resolution data converters, we can help utilities characterize the nature of the faults, reduce the average interruption time by 33%, reduce the restoration time from 45 minutes to less than 3 minutes. This allows the utilities to address the $100 per customer per outage that adds up to this $79 billion that I just talked about earlier. So here we have an illustration of how we can measure different types of faults. So when I press this first button here, a squirrel leaps into a transformer, causes an open. AC input goes flat. That generates a unique FFT. If I press the second button, a tree falls across a power line. It hits the wet ground. AC input races out of control by 100 times. And that is a short. That generates another different unique FFT. If I press the third button, I'm simulating a sag, which is when a big factory comes online with a lot of large motors that essentially the amplitude drops by 20% caused by that fault. And then the final simulation I'll show you is a frequency drop. When a bunch of EVs are leaving a charging station at the same time, which causes the frequency of the amplitude to drop from 60 hertz to 58 hertz. The benefit for the customer here is that we can help the utilities detect, diagnose, and locate the fault, and be able to help the utilities also restore power as quickly as possible by using intelligent distribution automation systems based on our high-speed, high-accuracy, high sampling rate A to D converters that can do those measurements, provide that benefit to the customer.